Hi, and welcome back to the Implementing and Administering Cisco Solutions CCNA 200-301 video series course by EC Council. My name is Glenn Singh. In this video, we are going to discuss various switching concepts, so let's dive on in. An essential thing to understand in networking is something called a collision domain and a broadcast domain. So let's take a look at what exactly is a collision domain first. A collision domain is simply defined as an area on a network that is connected to a medium that is shared with other devices. This means if a device sends traffic on a collision domain, it can be heard by all on the same shared medium. To quickly identify a collision domain, each port on a switch is equal to one collision domain, while each port on a router is equal to one collision domain as well. So this means to say, if a switch has 8 ports, there are 8 collision domains on that switch. Therefore, each port should only be connected to one other devices, and not to a hub and have a bunch of devices connected to a single interface. It's highly recommended only one device is connected to one switch port. The same applies to one device being connected to one router port as well too, simply to prevent any collision on that little network segment. A broadcast domain is simply a logical segmentation of the network itself. When a device sends a broadcast, it can be heard by all devices on that same logical network segment. To quickly identify a broadcast domain, we can consider that each port on a router is also a broadcast domain. So therefore, if a router has 3 interfaces, there are 3 broadcast domains that exist on that router. So now, let's take a look at actually identifying both collision domains and broadcast domains. So let's take a look at this diagram. Here we can see we have a router, we have a switch, switch 1, we have switch 2, and we also have a hub. And pretty much we have a small network. Now let's imagine that we have PCA here. If PCA sends a broadcast message, what will happen? Well, PCA will send a broadcast message to switch 1. Switch 1 will accept the broadcast and forward it out of all ports. So therefore, the broadcast message will reach the router. The broadcast message will reach PCB, also PCC, and PCD. But the router will not forward the layer 2 broadcast message. The broadcast is stopped by the router itself. So that's why you can say that each interface on the router, as in all these devices that are circulated here, represents a single broadcast domain. The same would be applied to devices on the right hand side of the network here. So therefore, if PCE sends a broadcast, who will receive the broadcast? Well, let's take a look. PCE sends a broadcast to switch 1. Switch 1 forwards it to the router, but the router will not forward it to any other device. However, switch 2 will forward it out of all other interfaces. Therefore, this here is another broadcast domain. But what about the collision domains? How can we identify the collision domains? Well, if you remember, we said each switch port is equal to one collision domain, and also each router port is equal to one collision domain. So let's actually identify our collision domains now. So this here is one collision domain. This here is another collision domain. Have another, and both switch 1 and the router shares a single collision domain. But what about this side of the network? Well, let us identify the collision domains here. The router and switch 2 shares a single collision domain. Each interface on the switch is also a collision domain. But we have a little tricky situation here. All ports, every single port on a hub is equal to a single collision domain. So this means to say that the entire hub itself is actually a collision domain by itself. Because if this device, and let's say device X, sends a message at the same time device Y is transmitting, guess what? A collision occurs here. So far, we have 2 broadcast domains, and we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 collision domains on this one network. So you're probably wondering, how do switches learn MAC addresses, and how long does a MAC address retain in a Cisco switch? To put simply, each frame entering a switch port, the source MAC address is recorded and learned by the switch itself. The source MAC address is stored in a very special table known as the Content Addressable Memory Table, or the CAM table. The default aging timer for any MAC address in the CAM table is 300 seconds. This means that if there's a MAC address that the switch determines that there's no activity for a period of, let's say, 300 seconds, the switch will automatically remove that MAC address from the CAM table. Switches use one of 3 methods to forward frames. There's a method of store and forward, there's cut through, and there's fragment free. So let's take a look at each one of these in a little further detail. The primary and default method that Cisco switches uses is known as a store and forward. This simply means the switch stores the entire frame in its buffer and checks the entire frame to detect if any error exists before it actually forwards the frame to the destination. Using this method simply ensures that there are no errors in the frame that's traveling across the network. Another method is known as cut-through. With cut-through, the switch will copy the destination MAC address of the frame into its buffer. This part of the frame that is copied is the first 6 bytes. The switch will then look up the destination MAC address in its CAM table for the destination port and forward the frame. This method simply provides faster speed and less delay. The third method is known as fragment free. With fragment free, the switch stores the first 64 bytes of the frame in its buffer. The switch will then check this portion of the frame for any errors, since most or more collisions exist in that location. If no errors are found, the switch forwards the frame to the destination. So you're probably wondering, what a switch will do if it receives a frame and it does not know where the destination is located. Anytime a Cisco switch receives a frame with a destination it does not have in its CAM table, the switch will store the destination MAC address in its buffer, but it will also forward the frame out of all interfaces except the interface that the frame originated on. And the frame only does this only in the event that it does not know where the destination for the frame is located. To view the contents of the CAM table, you can simply use a show MAC address command on a Cisco switch and it will present the results for you. On one column we have the VLAN, another we have MAC address, we have the type, and we have the port. So let's take a look at the second entry. We have a MAC address, which is this address here, is learned on Fast Ethernet 0/24. This address is dynamic, which means to say it was automatically added to the actual CAM table. And then too, we can also determine that this frame was learned on VLAN 40, so which means to say most likely Fast Ethernet 0/24 is configured with VLAN 40. In this video, we explored and understand both broadcast and collision domains. Additionally, we took a look at discussing various switch forwarding methods, and you also discovered how MAC addresses are learned and their aging techniques on a Cisco switch. In the next video, we'll be starting Domain 2, so you will be learning about the introduction and the topics that will be covered in the next domain. I hope this video has been informative for you, and I hope to see you in the next one.